Okay, let me continue. See here, weathering, as I told you, it is defined as mechanical disintegration, that is physical breaking down of rocks and chemical decomposition of the same through the actions of various elements of weather and climate. As I told you earlier, say temperature, then rainfall. These are two important elements of weather and climate, and through the actions of these two important elements, a big rock is broken into smaller pieces, and that is known as weathering process. Okay, is defined here. I told you that. So this is a big rock and it is broken into smaller pieces, and when it is broken, the number of surface area increases, as in this way. And here in weathering process, very little or no motion of materials take place in weathering. So in the weathering process, there is no transportation process. Okay, so simply the rock is broken in the same place. That is, it is an in situ process. Okay, in situ means taken in the same place or on-site process. So this is the meaning of weathering. So from your side, any question? Any question? Okay, let us continue. Then here, as mentioned here, weathering process are conditioned by many complex geological, climatic, topographic and vegetative factors. So these are the important factors controlling weathering process. Okay, so those are factors affecting weathering processes are this geology of the rock, that is the type of the rock, okay, the characteristics, physical characteristics of the rock, the hardness, the softness, then climate, then topography, the landscape and the vegetative cover. So these are important factors affecting weathering process. Out of this, climate is of particular importance, because climate not only affect the weathering process. Okay, so not only weathering process differ from climate to climate, but also the depth of the weathering mantle. That means a climate affects the type of the weathering process, as well as it also affects the depth of the weathering mantle, that is the thickness of the this weathering mantle. Weathering mantle means the parent rock, okay, the big rock. So let us see figure number 6.2. See here. Here this diagram shows the climatic regimes, different types of climatic regions, and the depth of the weathering mantle, the relation between the climatic types and the depth of the weathering mantles. See here, on the left side we have amount of precipitation given here, then comes temperature, and here the types of climatic regimes are mentioned. And see here, here we have this tropical forest zone. Here the amount rainfall is more than 3000 centimeters, that is 3000 millimeters, that is more than 300 centimeters, and the temperature is also more than 25 degrees Celsius throughout the year. And that is why the depth of the mantle here, as you see here, okay, the depth of the mantle as you see here is very great. See here, the thickness of the weathering mantle is very high. Okay, here it is very thick. Whereas here in these semi-desert areas, okay, or in the desert areas, the amount of rainfall is very low, but the temperature is high, and hence the thickness of the mantle is small. Okay, so in this way you have to read this diagram. Okay, any question regarding this diagram, regarding this figure number 6.2? Do you have any question regarding figure number 6.2? Okay, if you don't have, then let us proceed. Here there are three major groups of weathering processes. Okay, we have three major groups of types of weathering as mentioned here. Those are chemical weathering processes, physical or mechanical weathering processes, then biological weathering processes. So these are the three major types of weathering. And so very rarely does any one of these processes ever operate completely by itself. That means actually these three weathering processes are not independent of each other. Okay, all these three types of weathering processes are acting in the same place. Okay, in a place there may be mechanical weathering process as well as chemical weathering process, and biological weathering process also may be there in the same place. They are not independent. Okay, as mentioned here, quite often okay, sometimes there may be a dominance in one particular climatic zone. There may be a dominance of one particular geometric process. Say for example, here in the desert areas, okay, here in the desert areas the amount of rainfall is low, but here in these desert areas you may find the dominance of mechanical weathering process because there is less amount of rainfall. See, for the chemical weathering process, this water is required for the chemical reaction, and since in the desert areas the very little amount of rainfall is received, and that is why there is dominance of mechanical or physical weathering process. However, in the tropical forest area you may find all the three. Okay, this biological weathering process and chemical weathering process also there, as well as the mechanical weathering process also there. Now let us read these chemical weathering processes. So here we have these four important chemical weathering processes as mentioned here. Okay, those are the solution, then carbonation, hydration, oxidation, and reduction. Okay, oxidation, reduction, these are combined process. It is also known as this redox, okay, reaction. And these processes, these chemical weathering processes act on the rocks to decompose, then dissolve or reduce them to a fine clastic state through chemical reactions by oxygen, then surface and the ore, soil, water, and other acids. Now let us read in detail. Actually, in the old edition textbook, you may find detailed explanation of these chemical weathering processes. Okay, but this is the latest edition one, and that is why it has been deleted. However, let us read in detail. Okay, see here. So these are the important chemical weathering processes. The first one is solution. Let us read. So solution, as you know, in this process involves removal of solids in solution and depends upon solubility of a mineral in water or weak acids. Solution, you know, I think The best example of solution is here. See, we have a glass of water, and when we put a spoon of salt or sugar in the water, then it will be dissolved. Okay, if you stir this glass of water, then the sugar or the salt will be dissolved in the water. So in this way, some rocks are soluble. Okay, for example, limestone. This rock, for example, soluble, and when it contacts with water, then through the solution process, the materials of this limestone will be removed. Okay, and you know, soluble rock forming minerals like nitrates, sulfates, sodium chloride, potassium, etc. are affected by solution process. That means these minerals like nitrate, sulfide, sodium chloride, that is salt, okay, common salt, then potassium, these are different kinds of salt, are affected by the solution process, and so these minerals are easily leached out without leaving any residue in the rainy climates. Okay, see here, say for example, here this is a block of rock, okay, and so this is a soluble one, okay, and when there is rainfall, then the rainwater will dissolve this big rock. Okay, it will remove, the rainwater will remove the grains of the rocks. Okay, and in that process the whole rock will be reduced. Okay, and that is known as a solution process. The best one you may find in limestone rocks, as well as in these okay, types of minerals. Just think about the solution of salt in the water. Okay, like that, some minerals will be dissolved in the water totally, leaving any residue. Okay, leaving any residue, without leaving any residue. That means there may not be any remains, okay, after the solution process. Next we have this carbonation. Okay, actually carbonation and solution, these are related. Okay, here in this process also solution is followed. Okay, so let us read. Carbonation is the reaction of the carbonate and a bicarbonate with minerals, and is a common process helping in the breaking down of feldspars and carbonate minerals. So carbonate minerals here means dolomite, limestone. Okay, actually when this here you will be knowing the atmosphere contains carbon dioxide. Okay, atmosphere contains this carbon dioxide. Okay, and when there is rainfall, then the rainwater will dissolve this carbon dioxide, and it forms a weak acid, okay, known as carbonic acid. Okay, just here I think you may be learning in science also. So this is water, and what carbon dioxide is dissolved in water. Okay, and it forms a weak acid known as carbonic acid. Okay, that is H2 CO3. Okay, so in this way a very weak acid is formed, and this weak acid helps in the fast solution. Okay, helps in the solution process of the rocks. Okay, because of the carbonation process, because of this carbonic acid, the breaking down of these feldspars, then this carbonate minerals like dolomite, limestone, okay, is very fast. So calcium carbonates and magnesium carbonates are dissolved in carbonic acid. Carbonic acid means rainwater plus carbon dioxide, and are removed in solution without leaving any residue. Okay, so carbonation helps in the fast removing of the soluble materials, okay, without leaving any residue. Any question from your side? Okay, then let us continue. Then we have this hydration, another chemical weathering process. Hydration is the chemical addition of water. Okay, hydration means addition of water. And mineral take up water and expand. That means minerals and rocks absorb water, and when the mineral and the rock absorb water, it is expanded. The volume of the mineral and the rock is increased. Okay, and this expansion causes an increase in the volume of the material itself in the rock. That means, see here. This is a rock, okay, and when this rock absorbs water, then the volume is increased, it is expanded. Okay, the volume is increased. That is the point mentioned here. And calcium sulfate takes in water and turns into gypsum, and which is more unstable than calcium sulfate. Okay, that means when calcium sulfate absorbs water, it turns into gypsum because of the chemical reaction within the rocks. And this gypsum is more susceptible, okay, more unstable to the chemical reaction than the calcium sulfate. Okay, and this process, this hydration process, is reversible. That means when the water in the rock is dried up, then it can be back, it can be reversed. As I told you, when calcium sulfate absorbs water, okay, it turns into gypsum due to chemical reaction, and it is reversible. That means when the water is dried up, the gypsum may be turned back to calcium sulfate. Okay, so in this way, from calcium sulfate to gypsum, or gypsum to calcium sulfate. Okay, that means the chemical reaction is reversible. Any question from your side? Any question? Hydration means, okay, absorption of the water by the rock, and when the rock absorbs water, then the volume is expanded, the volume is increased, and there will be chemical reaction within the rocks, and okay, because of that, the characteristics of the rock is changed to another form. For example, calcium sulfate absorbs water and turns into gypsum because of the chemical reaction within the rock, and you must know this process is reversible. Okay, do you hear me? Okay, then let us proceed. Here the last chemical weathering process is oxidation and reduction, and this is a very common process. See, in weathering, oxidation means a combination of a mineral with oxygen to form oxide or hydroxides. Okay, so in the weathering process, oxidation means combination of a mineral with oxygen to form oxides or hydroxides. Say iron, for example, then manganese, then sulfur are mostly involved in this oxidation process. Okay, iron, manganese, sulfur, these are mostly involved in the oxidation process. And see here, red color of the iron upon oxidation turns into brown or yellow because of the oxidation process. Means when a piece of iron contacts with the oxygen, then there will be chemical reaction. Okay, and that process is known as oxidation process. And because of that, the mineral or the piece of rock will be broken this grain by grain. Okay, so you will be observing that red color of iron upon oxidation turns into brown or yellow. Just see here. Okay, see, this is the best example of this oxidation. See here, these rocks contain iron. Okay, these rocks contain iron, and when it contacts with the oxygen in the atmosphere, then the oxidation process is taken place, and because of that, rusting, okay, rusting is taken place, and that is known as oxidation. So here all the rocks are oxidized. And another one is also here. So this is also another example of oxidation process. Okay, here it is rusted. These iron contained in the rocks are oxidized when it contacts with the oxygen. Okay, and see, when oxidized minerals are placed in an environment where oxygen is absent, reduction takes place. Okay, see, in the absence of the oxygen, it is known as reduction. Okay, when minerals are oxidized, okay, in the absence of this oxygen, then it is known as a reduction. And such conditions exist usually below the water table and in the areas of stagnant water. Okay, oxidation is mainly taken place in the underground. Okay, see here, here in the aquifer, for example, this is an aquifer, a layer containing water, and here let us say some rocks are present containing iron. So in this case, because of the absence of oxygen in this layer, then reduction will be there, and reduction also will be there in the waterlogged areas. So for example, this is a waterlogged area, and if some rocks are found here, okay, in this waterlogged area, then there will be reduction process. And when there is reduction, okay, instead of this turning the rock into brown or yellow, see here, it will be a greenish or bluish gray. Okay, see, red color of iron upon reduction turns to greenish or bluish gray. Okay, so when there is a reduction process on a rock containing iron or manganese or sulfur, okay, there was a it will turn into greenish or bluish gray. See here, one here in this case, see here, this section, okay, this section, that is from here to here, it is brown or this red in color. So this is because of oxidation process. Okay, and here these white areas or greenish area here, this area is because of reduction process. Okay, so once it was under the water, and that is why reduction was there, and hence the color of the rock is white or this greenish in color. Okay, so this section is due to reduction, and this part of the rock is due to oxidation. Here we have this. Okay, one more photograph is also here. See here. So this layer, okay, so this layer is due to the reduction process. Actually here the color is greenish, okay, but due to the screen of the computer, so we may not be seeing as a greenish in color, but here this section is a greenish in color. Okay, and this is due to the reduction process. And I forgot to show some photographs relating with the carbonation and the solution. Okay, see here, this photograph shows the action of solution and the carbonation. Okay, see here, you may be seeing limestone blocks, and these limestone blocks are okay dissolved, withered, due to the action of the solution and the carbonation process. See here, it is dissolved. This is known as solution, okay, as well as carbonation. Solution and carbonation, these are associated with each other. Okay, carbonation helps in solution process. So another photograph also here. So this is another photograph of this solution and carbonation. So here the blocks of limestone are dissolved, okay, by solution process, and is helping by carbonation. Okay, so these are the 4 important chemical weathering processes. And now, do you have any question regarding these chemical weathering processes? Chemical weathering means decomposition of the rocks, okay, because of chemical reactions in the rock. That is called chemical weathering process. And we have 4 important chemical weathering processes: solution, then carbonation, hydration, and oxidation, and the reduction. So these are the important chemical weathering processes. And because of these chemical weathering processes, a big rock may be dissolved or decomposed into smaller pieces. Okay, any question from your side? Okay, then let us stop here for today. Please don't forget to send your names in the WhatsApp group for attendance. Thank you very much for joining my class.